All right, so a little bit of time has passed since I got mad and cut this thing in half, and I reprinted the iris, and I've kind of hooked it up, and it works. So I changed the design a little bit so that we've got the working mechanics of the box now. And we'll just leave that going for funsies. I printed this piece off, so now we're gonna pop this off. Take it back over to the bench. All right, that's actually gonna get really annoying really fast. Let's do it closed for now. All right. So we'll move all this out of the way, and this is the box that we're going to be pulling apart. So this one should a lot more easily than the last ones break loose and should work the way it's supposed to. So, I mean, y'all have probably seen this before, but we're just cutting these pedals right here free them up. And the biggest thing that I noticed that makes a big difference on these prints with these iris boxes is making sure that you have like almost under extrude. Like if you're not extruding perfectly, you want to err on the side of under extrusion versus over extrusion, because if you over extrude at all, these things are going to bind up and be pretty much impossible to break loose. Alright, so now we're going to crack the base loose from the top shell. So I had a little bit of a Arduino dilemma earlier. Oh my gosh, it has been an absolute mess. I got one of my viewers to help me with some of the code. Chris, thank you so much, man. We were going back and forth with the Arduinos and trying to figure out like what was going on with the sketch or the Arduino or the hardware. And the sketch was good. The code that he gave me should have worked, but for some reason the Arduino boards that I have, I say boards because it was like, I think we went through, let's just see, we started with this one. That one didn't work because that needed a weird funky servo library. Then we jumped to this one. That one didn't work because the USB device didn't recognize it. Then that one, same thing. And then I plugged this one in and that didn't work. And then that one has some weird library stuff. So I'm going to probably reassess and like buy another Arduino or something. I don't know. I am really struggling with just getting them to connect, which is weird. Chris and I were messing with it for a while, and lots of random issues, but I think I might just go buy like a fresh, unadulterated Arduino Nano or Micro or Mini or something, and go from there, because, oh my gosh, it's been frustrating. All right, so now we're just gonna kind of work these little leaves, and it should kind of slowly open itself up. I can feel it. I can tell this one's already it's gonna work. It's just gonna take a little bit of kind of fiddling with. Oh, you can kind of. Oh, I'm sorry. Totally out of the screen. All right. Do something like that. There we go. Oh, it wants to go. Come on. Just need to motivate it from this side a little bit more. And that's what I've found probably works the best is once you've kind of freed everything up, if you just get a screwdriver and push on the leaves. So if you look, the hinge is at these corners here. I'm not pushing on the side of the hinge, I'm pushing away from the hinge. So I'm trying to push this leaf around this hinge, so I'm pushing it there in hopes that it hinges out. And you can't get one to hinge out by itself. They all have to kind of slowly work their way out. So I just kind of go round and round and round equally, try to move them, press them out. Whew. I don't know if y'all could hear it, but that servo was buzzing, driving me crazy. All right. So we're slowly making some progress. Oh, come on, come on. Oh my gosh. Yep, this one will definitely work. It just takes some lapping, I guess is what someone corrected me. I said it just takes some like sanding to get all the pieces smoothed out. But apparently that's not the proper technical term, so we'll say lapping because, you know, internet stuff. So it's pretty sticky and gritty, I think is the best way to explain it. And so what I was doing to make it smooth is I grab the base of it and I grab the shell of it. I kind of push them together and I just kind of rotate them a ton. And that smooths out the mechanism. Alright, that might be... I want to make sure and get it smooth enough before I mount it, because once it's mounted on the goggles, if it's not very smooth, the servo will definitely stick. And it'll just kind of pull itself apart. One thing that I did notice once I've mounted everything here and kind of got it all worked out is that I was planning on having a piece go in between with a bolt through. And I think it works best with a bolt going in the bottom and just having like this half of the igloo. So in the next model revision, I'll probably just completely take off the top and just leave this like bottom half circle. That way you can put a bolt through the top or the bottom and like mount it either way. Like this isn't really necessary. So I didn't realize that until I was mounting everything, but that's kind of how the whole process works. You do something and then realize, oh, that was not ideal, and then change it. All right. So let's see here. We've got a servo. And okay, again, this is not ideal because I don't have the Arduino. So the servos are going to be going the same direction because I just have a single servo tester. So it's going to be winking essentially the way I have it set up. But ideally in the future with an Arduino, we'll have the servos going opposite directions and opening and closing simultaneously. So this servo will go like this. Actually, I'm going to put a little bit of glue on that, just to help it stay put. Alrighty. And then we need to make a linkage. There we go. And essentially it's just the same thing that we have on this side. So I'm going to make a little bit of a zigzag bend so that it fits in the servo horn. Let's see here. I zagged when I said zigged. There we go. That'll work. And let's see here. So I need to drill out the hole on this one just a tad so I can get that magnet wire through. I don't want to drill all the way through, I just want to get like most of the plastic out so I can, there's still a little bit of tension on it, but I can push it through. Something like this maybe? A little more. All right. Hold on, how do I want this? I want it to go like that. There we go. All right. So now we've got the same linkage as what's over here. And then I'm going to drill the hole out on this one so I can put the screw through it. Just like this. Might be easier to start from the side. All right, so now that should be ready to go. So, and the trick with, it's kind of weird to get these perfectly lined up. So what I was doing, I'll essentially hook up all the linkage and I'll move it to its, the location of maximum travel for the servo. And then I'll just kind of rotate the goggles into place and then glue that in. I found that that makes everything kind of line up a lot easier than trying to like glue it and then get this arm the exact proper length and all that stuff. So let's try. All right, so this servo, you can see, like I said, is all the way in the down position, which is open, and this one's going to be all the way in the up position, which will be closed because it's off the one controller. But whenever we put the Arduino in it, we'll get these synced up to be opposite, so the eyes make sense. But yeah, so I'll have this. If I have this all in the up position, then the goggles will be closed. So we'll leave it in that position. And then I'll unplug it so now it's no longer humming. I'll grab another screw so I can mount. Where did I put that? There we go. There's a good one. So let's just get this started. So it's easier to thread in here in a second. All right. So if I put the goggles here, I'd say go about there. So I'll bend a circle right up here. All right. Let's see if that works. All right, so now we're kind of taking shape. Let's see. Let's do a little quick dry run. This one's still a bit sticky. I might have to fiddle with that some more. Let's just test it real quick and see. Yeah, okay. So this one is still a little bit too sticky, so I'm gonna fiddle with just opening and closing it a bunch real quick to try to smooth it out. Let's take a look at some comments. Yes, Chris, it doesn't have to be sawed in half. That's really good. Are we there yet? Almost. Why can't you flip the servo? The servo's visible at the end of the product. Okay, so to answer some of the questions while I'm doing this, the servos will be there when it's all done. I kind of like the idea of having like a mechanism to move it, almost looking like eyebrows. Because the controller I have here is sending the same PWM signal to the servos, they're going to be moving at the same rotation. But whenever I have an Arduino programmed, I'll have them offset. So whenever one's going from like 0 to 90 degrees, the other one will be going from 90 to 0. That way they'll be synced up. But with what I have right now, they can't be synced up, which is not that big of a deal. Because honestly, what I'm doing right now is just kind of like a test fit up. Get all the grit out of there. Okay, yeah, that's starting to feel a lot better. This is such like a silly project, and I'm putting so much effort into it. I hope this is interesting to y'all. All right. We're almost there. Any other comments while I'm doing this? No, this is not my Halloween costume. Okay, yeah, sure. Sorry, for the people that just joined, let's see here. So far, I've printed the goggles, and then y'all saw me struggle with the whole iris box thing, but I finally got one mounted. And when I plug it in, I'll put this on just automatic. So you can see that the servo drives iris box and opens and closes it. And I'm getting this one, I mounted it, but it's still too sticky. That one I worked a while on to get it smooth so that it opens and closes. And see, it's still a little bit sticky, but I'm getting there. Once I get this smoothed out, I'm gonna mount it, and then we'll have both servos driving the iris boxes. I have an idea. All right. So this is kind of random, but while I'm doing this, I'm going to set you up on a rotating pedestal so that you can see kind of everything that's going on. I don't know, they might make y'all dizzy. I don't know, we'll see. Give you something to look at while I'm fiddling around. Oh no, my dirty floor. Oh. Yeah, Chris, I'm definitely going to be walking around town with these things. For sure. This is like the worst part of this entire project, is smoothing these things out. Actually, the worst part is breaking the stupid iris box loose. This is way more fun. Yeah, dude, here, you haven't even seen, I've got an entire like wall of like frames. I'm definitely big into flying. It is something that I really like doing. It's actually my main job. I commercially fly and do maps, or create maps and stuff with big drones and really nice cameras and stuff. Okay, I think I've just about got this smooth enough. Yes, sir, the Inspire 2 is my bird of choice for right now. All right, I'm gonna take you off the carousel of confusion. This is way smoother now. I think we're gonna have some good success. I'm gonna turn this guy off. Okay, let's put him all the way closed. So I'm gonna put this all back on. Alrighty, let's see here. That seems to be pretty smooth. So the trick here is getting it the lenses closed just enough and then lined up with the servo to be like where it's just about to go the opposite direction, and open it. Let's see here if we can see. That's not, I want it to be open a little more. Oh my gosh, it's still sticking. Come on, you. Let's see. Okay, so here's another thing that I've learned. If you try and rotate these off axis, like if you're trying to pull it at an angle, then they bind really easily. So with the wires, you can kind of bend them and then try to get them to pull at the iris box at a less of an angle and more like just straight in line with the axis of rotation. So let's see if, nope. All right, come on now. Oh, there it is. Okay. Oh man, it worked for like one second. All right, let's see here. I'm going to fiddle with it just a little bit more because it's definitely close, but there's still a couple catches that are keeping it from smoothly going. So I guess I'll put you back on the old carousel. I just realized how much of a mess everything is. Oh my gosh. Don't judge me. Dude, if you're looking to get into race quads, oh my gosh. You should definitely get one of the micro brushless, like, let's see, this guy here. Actually, let's just, y'all might have seen, boop. Y'all might have already seen this guy already, but this is it's almost like the size of a tiny whoop. It's a little bit bigger, but it has brushless motors, and oh my gosh, it has tons of power. It's lots of fun. So I'll be putting the designs and all this stuff up to make your own pretty soon. If you're wanting to make one, you should definitely look into that. And I've also got the whole Sky Party frame and all that stuff that hopefully y'all have seen on my channel. But I'm definitely a fan of flying FPV. It is a lot of fun. Oh dang! What one did you get from GearBest? Sounds like you have the same luck with quads as I have with Arduinos. Woohoo! Okay. Enough of that. Oh man, how did I get into flying quads for a living? Super long story. Maybe I can go into more details later. I got into it because I really like innovative technology, and I have a background in mechanical engineering. I got a degree from LeTourneau University, and really love being a part of something where there's a very complex problem and there needs to be some cool solutions. And I saw that for mapping and for a lot of the stuff that was being done with commercial air pilots and stuff, or planes, manned aircraft, that you could easily create just as accurate, if not more accurate, maps and stuff for civil engineering and topography and all that stuff. So I had started my own business and kind of launching all that, which is why I have a little bit of extra time than I used to. So It's kind of a little bit of background, but if you're curious about that, we can get into it more detailed later. Oh my gosh. Okay, so there's something, it's pulling on it funny. Let's see. Because it's pretty smooth. So let's see. I might just need to like glue it into place, and let's just do that. Let's just throw the Hail Mary, we'll glue it in place, and we'll see if we can get it to behave. We'll just put a couple of deals of hot glue on it, and we'll go from there. Yeah, sounds good to me. Okay, so we'll let that cool for a second, and then we'll slowly. All right. Oh, I can feel it still. Man, for some reason, it still is not happy. Let's see if we can see if it's binding somewhere. I mean, this is definitely one of those projects where like you can't just print it, pop it off the print bed, and then like it works. You gotta really invest some time into it. My goodness. What can I do? What can I do? Let's poll the audience. Any suggestions? Any thoughts? Let's see here. Couldn't connect a clean file even via. Whoa, Scott, you're a Laterno student? Heck yeah. Try and move the wire somewhere. Okay. Sweet, dude. That's cool. So, being a Laterno student, you get a 3D printer your freshman year, and it's basically like one of your first projects as a student. And they just kind of, I guess if you're an engineer, I guess, Scott, correct me if I'm wrong, is it only if you're an engineer, or it's any of the engineering disciplines, correct? All right, maybe the wire's too bent, maybe so. All right, sorry, I'm getting distracted. That's cool that there's some Laterno people watching. I love it. So that looks pretty straight. Let's move it to the... Man, this box. This one does a good job. This one... You almost have to work it. It's like somebody's like having a seizure. Their eyeballs. It cracks me up. I feel like this is a Rick and Morty type of deal. Seriously. Oh, come on. All right. There's something happening that I'm just not catching. All right, let's see here. Yeah, man, I'm trying. We're getting there. I think we'll definitely, here in a few minutes, we'll get all the kinks figured out. And the nice thing is, this is really cool. So you've seen me like sitting there like opening back and forth a ton. Once they get smooth enough that the servos can run them, I just put it on automatic, and then they just like open and close, and I can like leave, and for like an hour they'll just open and close. That's how this one got so smooth, is I left it going while I was out today, and it just like probably, I don't know, maybe a couple hundred cycles, open and close, and it's super smooth now. So once you get them so that they can open and close, you're pretty much set, because then you can just open and close them a ton, and they just get smoother and smoother. So let's see here. What am I? It's pulling. Man, that feels smooth in my hand though. What is going on? Hold on. Why is that? Let's see. Oh. Yeah, it definitely catches when I pull on that. Huh. That's weird. Okay, so when I grab it like this and rotate it, it's like buttery smooth. But then when I pull on it from here, it opens. It opens pretty smoothly. But when I go back, it's like catching. It's almost like something's rough one way and smooth the other. So we're just gonna try to smooth it out the old manual way. Let's see here. Okay, Scott, senior electrical engineering student. Printers only if you're engineering or engineering tech concentration. That's cool. No, I don't think I'm gonna do an enclosure for the servos, because I kind of like the way they look, and honestly, that would just mean a lot more time on this project, and I'm already kind of like, not like tired of it or not done with it, but I think I've invested as much time as I want to. I'm ready to. I've got some other projects that are kind of on a deadline with the quadcopters and the stuff that I want to get those out. So I think I'm gonna just get this kind of set up how it is with everything working, and then I'll definitely be posting the files, and y'all can download them. And I'd love for y'all to remix them or do whatever and make the changes that y'all want. And if you want to make an enclosure, or you can even change where the servos mount. You can put them wherever else to conceal them more. But this is definitely the biggest thing. Was this frame is a much better frame than the stock one. And so this gives you a lot more possibilities of mounting options or remixing or doing whatever you want to do. So I guess that's the big thing. That's my big contribution is getting a frame that can house everything a lot better and more sturdy. And then y'all can feel free to remix or remodel and repurpose however you want to. Okay. Let's try this. Let's just get this on there. All right. So close. Man. Oh my gosh. Come on, we're so close. All right, let's take a look at this. WD-40 I don't think would help. I heard we were going to turn it together. Whoa, what's up, Tyler? I haven't seen you in a while, man. Oh gosh, yeah, if you put these in FPV goggles, it would be game over. It'd be bad news. Let's see. Man. Let's just try doing some weird angles with the wire, see if that helps. Nope, that way does not help at all. Let's just like switch it on and see it self-destruct. This servo just popped off. The one that was doing so well. I guess I should actually glue this one down finally. Let's do that real quick. All right. I'm probably gonna burn out the servo. I don't want to do that, but I do want these stupid goggles to work. Man. Come on. Okay, well, I think I'm just gonna fiddle with this some more, and then, I mean, I can kill the live stream because y'all are, I appreciate y'all watching, but I know I'm not really making any progress. And what I was gonna do is just, you know, have them blinking, and you kind of get the idea of what it is going to be like whenever it works. Come on, God. Just one last time. Just, come on, you can do it. Oh my gosh. Why is this being so difficult? All right, we're gonna try to get this one last time. Come on, you can do it. There. All right, so yeah, but now it won't close. It'll open, but it won't close. I'm gonna work on grinding it down a little bit more, and but yeah, you get the idea. I'll definitely be updating you with any other once I get an Arduino and all that stuff. The cool thing that I'm really excited about is getting some lights in here, and then it'll illuminate your eyes. So okay, I guess that's another thing that I'm curious about. I've heard people talk about using infrared lights, which infrared is a wavelength that you can't pick up in your eyes, so like you don't see it, it's invisible. It's like what you use for TV remotes and such. So that would not light up your eyes inside the box. When you wear them, your eyes are so far back, it kind of makes it hard to see your eyes. So I thought it'd be kind of cool to have a light in there to illuminate your eyes. But we're gonna play with either illumination. I think infrared will probably be the best bet. And then having a sensor, and then we'll hopefully be able to get them like where it follows your eyes. So like this one will blink independently of this one, and you can control them with your eyes and when you blink. That's the dream. We'll see if we get it working, but yeah, I'll definitely be posting more live streams as I make progress. But as far as right now, like I think I just need to grind this thing down. I'll probably post a video on Facebook. If y'all don't check out my Facebook page, go ahead and do that. It's just facebook.com/Neatherbot, and I'll be posting some like shorter videos of just like whenever I make, you know, progress and junk. So be sure to check that out. And yeah, all right, I appreciate y'all coming and watching. Now let me check at the comments one more time. Let's see if I can answer any questions before I close this out. Let's see. Chris was saying, okay, hold on. Ooh, I got a bunch that I missed. Are cheap 3D printers any good? Okay, so to answer your question, that is a cheap 3D printer, and it is amazing. For like $400, you get a huge print volume, and it prints really well. I would definitely recommend the Creality CR10. It is really nice. I've had a lot of fun with it. And before the Creality, I had the Ultimaker, and that one served me really well. That was like before printers were really on the market that were like super affordable. So this one was pretty expensive. It's crazy now, like looking at it, it looks like something that like someone just made in their garage, like with wood and stuff. But this one was like really high end when I got it, and I printed so many things with it. It really got me hooked on 3D printing, showed me how powerful it was. And then it just kind of wore out because I had done so much printing. I'd like kind of redone everything about it, customized it, done everything that you could, and it just wore out. The linear rails and everything were getting old. And so then I saw that they had, you know, the whole Creality CR10 was hitting the internet, and everyone was freaking out about it. And I was like, oh wow, this looks like a pretty cool deal. And it has a whole different gantry system that I was interested in. So anyways, if you're looking for a cheap printer, cheap being like less than $1,000, $400 like shipped, these CR10s are amazing. I highly recommend them. You don't have to do the modifications that I did, and they still print really well. Okay, any other questions? Sorry, I just like went off on a tangent on that one. Let's see here. Best 3D printer. I'd still say, yeah, the Creality CR10. Put the wire closer to the servo. Like you mean like shorten the distance between the servo horn and the arm, the igloo piece? I played a lot with how to get this whole linkage to work. This is definitely probably not the best way, but I know that it works because it works over here. I mean, you see it, it's very consistent and it works well. I think the biggest thing is just that the mechanism itself isn't quite as smooth as, you know, what it takes to open and close. Drag length should be in equal length. Yeah, that's what I thought. That looks so good. Wait, okay, what would look good? I missed it. Oh my goodness. I'm getting a phone call. Not now. I'm live streaming. One way. Oh yeah, so like you could. Oh, it's like a mirror. Okay, so someone said it'd be cool to have like a one-way glass. So like it's when someone looks in, it's a mirror. So you see a reflection out, but from the inside, looking through the glass, you can see everyone. That would be kind of cool, especially with some lights. That might. Oh, dude, oh my gosh. Okay. What if you did? I get myself in trouble because I say these things and then like people want me to do them. But what if you did like the two one-way mirrors, you know, with lights in the middle to make the infinity mirror effect? So when you looked inside, it was like an infinity mirror going like into the person's head, but the person wearing them could see out. That would be pretty sweet. That would be cool. That'd be cool. Let's see who else is saying stuff. Xavier, sorry man, you came in late. But yeah, we put the iris box, the second one on this, and they both work with servos. This one's a little bit sticky, so I'm gonna have to sand or lap it a little bit more. Oh snap! Is Dr. Green still Eterno? Oh my gosh, that guy was a great guy. Dude, you do not want me to help you with your thermo homework. Thermo was like my least favorite class. There's so many freaking equations in thermo. It's unlike anything else. Even dynamics had less equations than thermo. Okay, then Chris was saying, no, a closer hole on the arm. Oh, Chris, I got what you're saying. So, okay, if I was to move this linkage closer, it wouldn't move as much. I guess, let me try to explain that in a way that makes sense. So if I did, oh, it's still on, okay. Well, shoot. How do I explain this? Here, we'll do this. Sorry, this is like a lot of effort for like a simple explanation, but you asked a question, so I want to answer it in a way that makes sense. Okay, so if you think of this, oh man, we're spinning around. If you think of this as like a linkage arm itself, so from the center of the servo to the end of the arm, we have a set distance. Now that distance, think of it as like a lever arm, and it's moving, right? So we have the distance from this point at the tip. So like let's say there's 2 points. Let's say the bottom dot and the top dot. Okay. Watch how much the bottom dot moves in arc length compared to the top dot. That top dot moves a lot more. So if I moved this linkage, I need a certain distance of throw from the servo to open and close because it has to rotate so much. And I'm kind of on the edge of not having enough throw. So if anything, I need the servo horn to be a little bit longer. That means that it requires more torque from the servo to open and close because the reaction arm is longer. If I took this linkage and put it inside, the servo would have a lot more power to open and close because the moment arm would be a lot less. Sorry, this is getting kind of nerdy or whatever, but like that's kind of why I have it this distance, is because with this length from the center of the servo to where the linkage starts, I would have to, okay, cool, you got it. Thanks for making the comment because I'm kind of like I'm trailing. Okay, let's see here. Yes, install those Arduino drivers and the zip. Okay, Chris, and I'll definitely get with you later about the Arduino stuff because right now I hate Arduinos and you're my only hope, man. Holy crap, Green is the associate dean. Wow, that's exciting. Good for him. But you have so FA Ox says, true, but you have enough of the way left and you need more force at the arm. I'm not exactly sure what you're saying. I mean, okay, honestly, there are a million ways to skin a cat. There are probably a bunch of different ways to this linkage. I could make this arm longer, thus requiring less force to pull it, and then I could reduce that. There's tons of different combinations of linkages to kind of get the same system. This is just what I chose because I wanted to keep the profile small and it's kind of how everything kind of worked out. So yeah, there's definitely some better ways to set up the linkages. As of right now, this is kind of what I've got. Once I get everything working, then we can play with maybe optimizing the linkages or whatever, but I can't mess too much with these arms because they're kind of set. And I don't really want these sticking out really far. I wanted to keep this linkage, and I might even make this smaller. I don't know, but yeah, so that's kind of why that is the way it is. Oh my gosh, gears would be sweet. I totally agree. All right, Chris, see you, man. Yes, and I thought of that. Gears would be pretty cool. So I could do like a gear here and a gear here because they rotate in opposite of each other. And then I could just do like one like center motor, or like one motor on the side, and it drives the entire like gear set. That would be really slick. Again, I just didn't really have or want to put that much time into figuring all that out. So I'm just trying to get this working, and then I'll post the files. And if y'all want to run with it and put some gears on it, that would be awesome. I totally would love to see that. But yeah. Okay. I think that answers all the questions. I am going to go ahead and close the stream. And thanks for watching, guys. It's cool. I enjoyed being able to share this project with you. And as I make more improvements or as I do anything else to it, I'm definitely going to be doing some more live streams. So let me know what y'all like in the comments, and hopefully we can keep doing some cool projects. All right. Thanks, guys. See ya.